What's going on in our universe? No one knows for sure, but scientists are hard at work coming up with a so-called theory of everything to explain, well, everything. No one's decided on one yet, but there are certainly ideas. One of these is known as string theory, but what is it? In order to understand, we need to take a few steps back. Right now, scientists have two other fundamental theories. The first is Einstein's theory of relativity. Einstein had this idea that, on its own, space is like a flat plane. When large objects are placed on it, the plane is warped but remains a relatively geometric sheet. This can be visualized with a piece of cloth. It starts out flat but is warped when a baseball is placed in the middle. The dip causes other objects to move towards it, and that's essentially how gravity works. Our second theory, known as quantum theory, doesn't work for super big things but instead for super small things. Quantum theory, or quantum mechanics, is practically a field of physics in itself. What we need to focus on is that it provides us with three important forces: strong nuclear, weak nuclear, and electromagnetism. These and gravity make up the four essential forces of nature. Unfortunately, general relativity, which provides us with gravity, doesn't exactly work with quantum theory. While general relativity asks for a smooth, predictable plane as a basis for space, quantum mechanics wants a field of chaos. What they need is a unifying theory to get them to get along. How about string theory? Yes, but we still need some more background before piecing it all together. Okay, so everything is made of atoms, and atoms are made of subatomic particles, and those are made of quarks. But wait, according to string theory, things get even smaller from here. Inside of each particle, there's a super small string of energy vibrating in multiple dimensions. The vibrations of the string determine the type of particle. Picture a violin. When the strings vibrate in a certain way, a certain note is played. Similarly, when a subatomic string vibrates in a specific way, it produces its own specific particle. Well, our four forces are thought to only exist when their own force carriers, or messenger particles, are thrown back and forth between two particles of matter. The four force-carrying particles would be gluons for strong nuclear, W and Z bosons for weak, photons for electromagnetic, and gravitons for gravity. Just like other particles, these would contain their respective strings. To understand what's going on, imagine two people playing catch, but replace people with particles and replace the baseball with a graviton. Each time the graviton is thrown, the two particles get closer as they are being pulled by the force of gravity. The more times the graviton is exchanged, the stronger the force gets, and exchanging it at all causes the force to exist. So the forces follow the same rules, but what about our other big chaos versus calm problem? Well, if strings exist inside every particle, then they would essentially be everywhere all the time. Then, the chaos that quantum mechanics had previously observed could actually just be the countless vibrating strings. Plus, since the strings are spread out and resting on a smooth plane, it works out with general relativity as well. Thus, string theory unites our two previously conflicting ideas into one great theory of everything.